In these problems, we are solving equations that involve complex numbers. And remember, complex numbers include imaginary numbers and real numbers. The trick to know here is when you've got a statement like this, 2x minus 3i equals 3 minus 9yi. At first it looks like you've got two variables and just one equation. So how could you possibly solve this? Usually when you have two variables, you'd need a system of equations. Well, the thing about this is that if this statement is true, if this complex number really does equal this complex number, then the real parts have to equal each other and the imaginary parts have to equal each other. So you're going to split this into two things. Find anything with an I in it, set those two equal to each other, so negative 3i equals negative 9yi. That's one equation to solve. And then the other equation is the real parts, which we've got 2x equals 3. Well, solving for x is pretty simple here. We're just divide by 2. We get x equals 3 halves. And to solve for y, what we're going to do here is divide by a negative 9i. When we do that, over here, that's all going to cancel, leaving just y. Over here, negative 9i, the i's will cancel, and then you have negative 3 divided by negative 9, that's a positive 1/3. So y equals 1/3. Let's try one more like that. This one says, if 4x minus 8i equals 7 minus 4yi, determine x and y. So once again, we're going to find the imaginary parts and set them equal to each other, and the real parts and set them equal to each other. So here we have negative 8i equals negative 4yi, and we have 4x equals 7. Solving for x just involves dividing by 4, so we've got 7/4 for x. And solving for y here, we're going to have to divide both sides by a negative 4i. So the i's cancel and the negative 4's cancel here, leaving just y. And over here, the i's cancel, and it's negative 8 divided by negative 4. That's a positive 2. So y equals 2. Let's look at one slightly different type of problem. In this one, we're just being asked to solve for x, and it's going to involve imaginary numbers here. So the way I would approach this is to isolate that x squared and then take the square root of both sides. So let's try that. First, I'll get rid of this 27 by subtracting it from both sides. So we've got 2x squared equals negative 27. Then I'm going to divide by 2 to get that x squared alone. So I've got x squared equals negative 27 over 2. Once I've got that x squared by itself, I can go ahead and take the square root. Now remember, when you take the square root, you're going to get two values as solutions, the positive and the negative value. So over here we'll have x, over here we'll have positive and negative square root of negative 27 over 2. Now there's some simplification to be done here. Let's work on, well, this square root of negative 27 over 2 is the same thing as the square root of negative 27 over the square root of 2. And this square root of negative 27, that's going to be, well, negative 1 times 3 times 9. So I can pull that 9 out, I can pull the negative 1 out, so that would be a 3 and an I. So this is really going to be 3i times the square root of 3. So let me bring it down here. So far I've got x equals plus or minus 3i times the square root of 3 over the square root of 2. And we don't like these radical signs in the denominator, so I should probably rationalize the denominator by multiplying by the square root of 2 over the square root of 2. On the bottom there I'd get 2, and on the top I get square root of 2 times the square root of 3 times 3i. I think I'll call that square root of 6, so this would be 3i times the square root of 6. And remember, this was all positive and negative, our two solutions. And that's our answer for that one. So that's a little bit about solving equations and having to deal with some complex numbers while we do it. My name is Larry. I'm a teacher at EdVisions Off Campus. It's an online project-based school in Minnesota. If you're interested, you can check us out on the web at lovethisSchool.org. Thanks.